Okay. Now, before to introduce the next one, I just make a short presentation of a speech that I this morning, but we were too late. I do that. In this is technology. That's the technology that is coming. Especially, I'm talking also with the people that specialize in hemp, because they are used to decortication and degumming by using enzyme. If I'm not wrong, I'm thinking. But there are other opportunities to use. So I mean, textiles, the use of the enzyme is well known. There are some of the processes that use enzyme to, for example, decoloring, or they use the gumming, like in hemp, or other process. But in this case, the use of enzyme is in a different concept. We use to recycle products that otherwise are not possible to be textile process, textile material cannot be used anymore. And I'm talking about the laminated or coated textiles. There is a huge lot. I mean, honestly, it's so difficult to find information and numbers on internet. But most of the garments, including a jacket, contain laminated. I mean, material that's a two substrate. That's normally stitched together, mechanically or chemically. And therefore, why we have not to talk about some of these material, the laminated, just example, the luggage, the raining coat, the shoes, the garments for army or for people on the road. So there are many products in textile that are normally rich enough because they're made with the specialty fibers that are not considered as a waste. They just throw away. Maybe make enough money at the beginning. But now the scope is also to use a natural technology to reuse it. Special fibers means also highly cost fibers. For example, like polyamide 6,6 or aramidic fibers, carbon fibers, but also wool, but also multi-layered cotton. Why not? Why did we? So how I got that idea? Oh, sorry, not me, but a lady that is not here today because it's sick at home. They find a mix of enzyme that has been developed for the delamination of paper. You know, paper packaging, especially food packaging, are multi-layered. The Tetra Pak has 6 different layers that are stitched together. And she found a way through the enzyme to separate the paper from the plastics and from the aluminum. Okay, I said, oh, this looks good. Why don't try to use it for the delamination of textile waste? That's an enormous quantity, difficult to say also. I try also to, as I said, to find some volumes. I just, in Report Linker, they talk about up to $5.5 billion in 2028, with an increasing. It's true that is a possible increase, and the reason is a part of the war that's unfortunately are growing in the world. But there are many, many applications that require the high technical stuff, including protection, personal protection, building protection, our leggage, that's a stupid leggage, but made with a filament or with textiles, need to be recovered. And from this idea, we tried, and finally, we got the results. Now the point is how to apply in the textile process. And this is my job. I'm a technologist. I'm studying the process. And we found a way to offer two types of solutions, so discontinuous and continuous process. As I said, in some part of the textile cycle, this type of enzymes are still used. But the problem is to delaminate to material. So we are now producing the first pilot line, industrial pilot line, unfortunately not in Europe, but in Asia, where this is the largest production, especially in Taiwan, where the largest production, world production of a laminated material. And then I design, if it's going on, I design this kind of simple drawing, of course, because I don't want to say too much. And with using technologies like tumbling, drying, and then thanks to the movement and the bacteria, the enzyme mix inside the tumbler, we can remove it, and we cut the pieces, of course, in pieces, medium, small pieces, the raw materials, and then we achieve automatically in room temperature, and in 20 minutes, the separation. We have the separation. The delamination helps us then to recover both the film, polyurethane or poly-PVC, and the textiles. As I said, they normally are expensive fiber. This is another idea of the continuous processing. This technology is largely used for scouring, the wool scouring. I used the same idea. And then we are able to produce up to 300 to 600 kilos hours in a machine that's to be built online with a very, very few energy. As I said, don't need any energy, and only for the motors. That's a some example. Unfortunately, Alicia Garau, so the lady, she's ill, so I have no sample to show you. Believe me, that's I did it. Like this one, from the jacket. This is a coat, for raining coat. Has been from this delamination completely. 3 materials. This is leggaging. The 2 materials are the PU and the textiles have been completely reopened, and then we can reprocess in the lamination process or shredding process. Okay, this is the fibering system. But as I said, the main benefit, and then I'm going conclusion, room temperature process, natural chemical-free, synthetic-free chemicals process, valuable recovery of otherwise lost material, and suitable for, against a new multi-layer technical textile and technical fibers recovering. That's we are just at the beginning, but it's another way to prove that so we can go on in technology, just adding experience that's coming from a long history of textile industry. The enzyme, of course, are not. It's a secret. I can explain you which kind of enzyme, of course. Okay, that's it from my side.